Okay, so today's lesson we're going to continue to talk about adding and subtracting radicals, but as a little bit of a review from yesterday, there were two things that have to be the same in order to add or subtract radicals. Who can tell me? Okay, go ahead. Okay, two items that have to be the same. Somebody said the radicand. Okay. And where would that fall? If you're looking at the cube root of 3, which one of those is the radicand? The big 3, the number under the radical, okay? What else has to be the same? The index. And which one is the index? The little 3. Okay. So, now I'm going to tell you right now, everything that we're going to be doing is going to be square roots. So you're not going to have to look for something like a cube root of 2 versus a square root of 2. Okay, so let's just remember what we did yesterday. So if we had the 2 square roots of 3, we're adding 5 square roots of 3, and we're subtracting a square root of 3. So what you do is you add each one of these outside numbers or subtract them. So 2 plus 5 is 7 minus 1 is 6 what? Square roots of 3. Okay? 6 square roots of 3. Okay, do this one for me real quick. Okay. Work that one out for me. Okay, so you've got 5 plus 6 is 11 minus 3, 8 square roots of, 7, 8 square roots of 7. I was looking at the top. Okay, so those are pretty basic. Those are pretty simple. So what happens when you have to Okay, so what happens if you have non-like radicands? Okay, an example of that would be, you've got the square root of 12 plus the square root of 48. Okay, so write that down. I'm going to add the square root of 12 and the square root of 48. Now, that is not the square root of 60 because they are not like radicands. Okay, now this is something I'm not sure if you've been exposed to before. Have you ever been exposed to a factor tree? Okay, very good. Now let me tell you how I do my factor trees. Now you can start off and you could do 4 times 3 on this. But I like my factor trees, and I don't know how many of y'all are kind of OCD like me, but I kind of like things in order. And so how you achieve an orderly factor tree is to start with the lowest prime number, which is 2. And see if 2 will go in it. And keep using 2 until 2 runs out. 2 doesn't work, then try 3. If 3 doesn't work, then try 5. If 5 doesn't work, try 7. Okay? So that's what we're going to do. We're going to factor tree this. So you may want to jot this down as a memory. So I'm going to start with 2. 2 and 6. And then I can break down 6. I can still use 2, correct? 2 and 3. Okay. Now, because this is a square root, and when you square something, how many times are you multiplying it? 2. Twice. Okay. When you square something, you're looking for groups of 2. Now, the reason I don't like 4 and 3 is because the bigger your number gets, the crazier your branches can be. Do you kind of see what I'm doing right here? I like to go all the way down on one side until I'm done. So I'm going to look, and Daddy has a rule of the house, of a radical. I'm going to call that my house. And Daddy's rule is you can leave when you have a buddy. Okay? You're not going out with a buddy, you have to stay home. So, I'll look. Do I have a 2? I have a group of 2s. Now look at little old 3 over here. Is there another 3 that I can group with it? So I typically box it in. So what's the only thing that can leave the radical? A 2. 1, 2. Even though you've got a group of, you got a pair of them, you've only got one pair. Okay? So that's going to be 2, and what has to stay home?
3.
A 3. Okay? So now we're going to factor tree 48, and you could get crazy with 48. I mean, and it could be long, and the branches could be all out there, and you don't know what's at the end of the branch, and you don't know what's factored. So stick with 2. So we're going to do 2 and 24. Then I know I can always, I never have to do this one. I can always do this one. Stick with 2 and do 2 and 12. Stick with 2. 2 and 6, stick with 2, 2 and 3. Okay? Now this could really be crazy if you didn't have it nice and neat, but if you want to factor tree it another way, that's okay, but just be sure you don't miss any of the ends of your branches. So, I'm going to start along here. I have a pair of 2s. I have another pair of 2s. And this poor little old 3 has to stay home. So how many groups of 2 do I have? Do you remember what I do when I have more than one pair? What do I do with them? Y'all remember? No. Multiply. Okay, so you might want to write that down. More than one pair. Multiply. That also rings true if I happen to have another number that stayed under the radical. More than one staying home, multiply. Okay, so more than one pair, more than one thing leaving the house, multiply them. More than one thing staying home, multiply them. Okay? So I've got a 2 and a 2 leaving the house. So what gets to leave the house? 2 times 2 is 4. What has to stay home? 3. So now, do I have like radicants? Yes. Now I'm going to move this up so everybody can see it. Now I have like radicants. Now I'm going to give you just a little heads up. About 98% of the time, if you're doing this, you will be able to combine them. Not 100%, but most, and especially if it shows up on a test. If it shows up on your examination in May of your freshman year, then you're going to be able to get them down to the same radicand. So I've got 2 square roots of 3. I'm adding 4 square roots of 3, so I have, what's my answer? 6 square roots of 3. And that is my final answer. Okay? Any questions so far? I'm going to work a couple more examples. Okay. Write these down. Okay, we're going to write these down. All right, let's start factor treeing the 50. We're going to start with 2. So that's 2 and 25. Now I'm going to break down the 25. 2 won't go into it. 5. So I've got 5 and 5. Now, let's see what gets to leave the house. Does 2 have a buddy? Okay, I'm going to box it in. Does 5 have a buddy?
Yes.
So what gets to leave the house? 5 square root of 2. Now let me show you why that is. Everybody look up here. 50 is really made up of a perfect square 2 and 25, right? So that's like saying the square root of 2 times the square root of 25. Do I know the square root of 2? No. Do I know the square root of 25? It is what? So that's 5 square roots of 2. You're multiplying them. That's why. But, and I used to teach with somebody who made their students figure out the perfect square in the number. But some big numbers, it's not very obvious. You know, like something like 81 times 3. And you get 243. You may not know what the perfect square is in that, or 49 times 6. You see what I'm saying? So, for me, it's always been easier to teach my children to factor tree. So let's factor tree 18. Start with 2. 2 and 9, 3 and 3. The 2 doesn't have a buddy, the 3s do. So what gets to leave the house? 3 square root of 2. So we can now combine these, where these couldn't have been combined before. So what do I have? 8 square roots of 2. Okay? All right. Let's see if we can do one more, and I'm going to try to think of... Let me do a subtraction one here. Okay. We're going to factor tree this. So everybody look here, 2 and 27. Okay, 27 is not divisible by 2, so then I step up and do 3 and 9. 9 can break down to 3 and 3. Okay, everybody look up here and watch me. Do I have, along my branches, do I have another 2? Now, let me make this very clear. They do not have to be next to each other. So I just haven't come up with any examples right now that there was a 2 down here. Okay? But if there was a 2 down here, you can absolutely pair those off. They do not have to be next to each other. I don't want you to make that assumption. So there's no other 2. Do I have a pair of 3s? It doesn't matter which pair you circle. But then does this 3 have a pair? Okay, so then it's going to stay home. So what's going to leave the house? A 3. Now, going back to my old notes, more than one staying home, what do we do to it? So I have a 2 staying home, and I have a 3 staying home. So that's going to be square root of 6. Okay, now let's break down the 24. I'm going to break down to 2 and 12, 2 and 6, 2 and 3. Okay, I do see a pair of 2s right here. Once again, it does not matter, but you can't share a 2 to make 2 pairs. You have to have even numbers. This 2 gets to stay home. This 3 gets to stay home. So what's going to go on the outside? 2 square root of 6. So now these have the same radicand. 3 square roots of 6. I subtract 2 square roots of 6, so I have 1 square root of 6. And if you want to put the 1, that is okay. All right, questions? Okay, I'm going to pass out